Hello, today we're gonna discuss one of the most important physics classes that you really wanted to watch. First, it's Mariam Ahmed, and today I'm gonna discuss with you conservation of angular momentum. But first, I wanted you to know or to make a summary of the rules of angular momentum that you already learned in the sections or in the previous videos in the channel. And I'll write them here to know more about our topic today, which is the conservation of angular momentum. But at first, you should know what that rules. So let me clear all drawings and write them. Okay. First of all, we know that there's a linear momentum, which is B. And we say that it's equal m, which is the mass, times v, which is the velocity. And we say that there is an angular momentum, which is L, which is equal R, or the radius, times the linear momentum. And we can replace the R, or the linear momentum with that, as we say, so L may be equal, R times M times V. And we also say that L may be equal I, which is the moment of inertia, times the omega, or angular velocity. So those are the rules that we learned about the angular or the momentum, linear and angular momentum. And that rules we will use a lot in our session today, because we're gonna know what's the conservation depending on them. What is the meaning of conservation of energy in the logical case? We say that there's a conservation of energy when the input and output is the same. So, however, let me say the linear momentum. The linear momentum here, so I'll make that. The linear momentum here is equal m times v. So if I said that m is reduced, so the v must increase. To make the b, which is the linear momentum, at the final is the same, not changing or not give another value or something like that. No, it's conserved. So m is reduced or decreased. So please, sorry, here. So B, there's a linear momentum which is conserved. So we can say that if M decreased, so the V increased. So again, let me say that again. What is the meaning of conserved? The input equals the output. Or if there's a change in something in the equation or in the rules, reduced or increased, so the another value must reduce or also increase to make the linear momentum at the final conserved. So let me draw an example to understand me a lot, or more than that. Okay, if we say that the at linear momentum, if we say that linear momentum, okay, or let me say at the as a rule, okay, we will drop an example in that rule. Okay, if we said that there is a body here moving about that center, okay, this is the body, this is the distance r, okay, and the velocity equal 12. Okay, let me say that. So if we say that r is reduced or decreased, it was 3 and become 2. Okay, it's 3. and become 2. So what will happen to the velocity? It's in the r is decreased, so the velocity must be increased to make the angular momentum at last be conserved. So let me remove all of that to make it more clear. Okay. So again, what if we had an object here? There's objects, okay? I don't know. Yeah. This is a circle object here. This is R. And this is V. What will happen if R decreased like that? Okay, I'll draw. Decreased like that. So the V increased. Yes, that's right. What will happen if R decreased by half? So V increased by 2 to make it at last conserved. So I will draw another example, or I will say something. I'm gonna ask you a question. Why if we change R, the only V is changed? Why it's not M? Because the mass of the body cannot be changeable. We also can change the variables that can change from something to another. We can change the velocity, we can change the R, but the mass of the body itself cannot be changeable. Okay. So this is our topic today. It's not more than that, but I will gonna say something. So this is linear momentum and angular momentum. Okay, if we increase R, so the B decreased. If we decreased R, so the so the R increased. Here, if we increased R, so the B decreased, and vice versa, as I said. Okay. Here in the angular momentum, or that rule of angular momentum, we can say that if the moment of inertia increased, so the angular velocity will be decreased, and vice versa too. So I will gonna make something for you also to know. Okay, let me remove all of that. Here, if we say that the angular momentum, as we said, equal moment of inertia times the omega. So we can say that angular momentum final or initial will be angular momentum final, because it's, as I said, it's conserved. So what is the meaning of conserved? It's the final equal initial, and there's no change in the momentum. If there is a reduce in some variable, so there is an increase in that another variable. Okay, so I initial omega initial will be equal I final omega final. So this is the meaning of conservation. Okay, this is our topic today. I wish that you know what is the conservation of that topic, or the angular momentum. So please stay good, and thank you for your listening to my video, and bye bye. Thank you.